2.6 is all about rates, ratios, and conversions. By the end of this, you should be able to find a unit rate. Okay, starting with some vocab, a ratio compares two numbers by division. Okay, the two numbers that you are comparing will both have the same units. Okay, so for example, if I was talking about students in class, okay, there's 4 girls to 3 boys. A rate compares quantities measured in different units. Okay, so for example, things like 40 miles per hour for 1 hour. Dollars per gallon, things like that. A unit rate is a rate with a denominator of 1. Okay, if I'm paying $5 for 1 book, that is a unit rate. Even that 40 miles per 1 hour was a unit rate because it has a 1 on the bottom. Okay, there's actually 3 different ways to write a ratio. You can use a colon, which would be like comparing 2 to 1. You could actually use the word 2 by saying 2 to 1. Or you could write it like a fraction, compare it as 2 to 1. All right, comparing unit rates. Remember, unit rates have a 1 on the bottom, denominator of 1. You are shopping for t-shirts. Which store offers the best deal? Okay, right now none of these are unit rates. What that means is I need to figure out how much each store charges for just 1 t-shirt. If I know for store A, if I know that for store A I have to pay $25 for 2 t-shirts, I want to know how much am I going to pay for just 1 t-shirt. All right, well, if they're all the exact same amount, I'm just going to do this 25 divided by 2, and I find out that store A is going to charge me $12.50 for 1 t-shirt. Okay, store B has me paying $45 for 4 shirts. So if I only wanted 1, how much would I pay? 45 divided by 4 makes me pay $11.25 for 1 shirt. Okay, already a better deal than store A. Store C has me paying $30 for 3 shirts. So how much would they make me pay for 1 shirt? That one we find out I would pay $10 per shirt, which is cheaper than the $11.25. So store C would be my best deal using unit rates. Okay, a conversion factor is a ratio of 2 equivalent measures in different units that always equals 1. Okay, so when they tell us that 1 foot is really equal to 12 inches, those two things are equal, and so that is a conversion factor. That is how we convert from feet into inches. There are many examples, and I actually attached a worksheet to your Google Classroom that has a whole bunch of conversion factors in it that you will want to use for the rest of this lesson, and your assignment. All right, we are going to have to convert between one unit to another, and sometimes we're only going to have to convert once. Sometimes we may have to convert twice, but let's start with 1. Okay, choose and multiply, or what is the given amount converted to the given units? Okay, so they give us 330 minutes, and they want us to change it into hours. All right, so what we're going to do is we're going to start with our 330 minutes, and we have to figure out how to change that into hours. All right, I'm going to look at my conversion chart if I don't know the answers to this, but I need to figure out how hours and minutes compare. Also, I want just like numbers and variables can cancel if they are across from each other when we simplify, so can units. So if I want my minutes to go away, I need to have them across from each other. So if I have minutes on top on the first ratio, I need minutes on the bottom on the second ratio. So now those are gone. What I'm trying to get is hours, so that's what has to go on top. Now I need to know to fill this ratio in, how hours and minutes are related. I know that 1 hour is the same as 60 minutes. Okay, and now my only unit that I have left is hours, so my final answer will be in hours. And I'm going to multiply this fraction, or these ratios, just like I would fractions, so straight across. I have 330 on the top, 60 on the bottom, and then I should actually divide those, which gives me 5.5 hours. So 330 minutes is actually 5.5 hours. Let's try this one. What is 1,250 centimeters converted to meters? Okay, so I'm always gonna have at least two ratios, and the first one is gonna tell me what I started with. So I have 1,250 centimeters, and I need to convert that to meters. Okay, remember that I need my new unit on top so that my centimeters will cancel each other out by being diagonally across from each other. Then I'm going to look at my conversion chart and figure out how meters and centimeters are related. If you're not sure, remember, I don't know if you learned this in 7th grade or just the end of 7th grade, but there's this kangaroos hop down under drinking chocolate milk. Okay, these are all the units: kilo, hilo, deca, deci, centi, and milli. And this is just your basic units right here in the middle. So meters would fall there. Centimeters is over here. And I would have to move my decimal 2 places. So there are 100 centimeters in 1 meter. Okay, now when I multiply straight across, I end up with just meters, but I have 1,250 over 100, and then I divide that out and I get 12.5 meters. All right. Convert the given amounts with the given unit. I'm going to give you a few minutes to try this on your own, and then you can come back and check your answers. "15 days is actually 360 hours. 60 feet is the same as 20 yards. 5 hours is really 300 minutes. 25 kilometers is 2,500,000 centimeters. And 3 miles, is really 15,840 feet. Problem 3, converting units between systems again. The CN Tower in Toronto, Canada is about 1,815 feet tall. About how many meters tall is the tower? Use the fact that 1 meter is about 3.28 feet. Okay, so remember, we start with what we know, which is that the tower is about 1,815 feet. And we know we're trying to change that into meters, and we want our feet to cancel out. Okay, so how are meters and feet related? Well, they just told us that 1 meter is about 3.28 feet. Feet will cancel, and when I multiply straight across, I end up with 1,815 over 3.28, and when I divide that out, I get approximately 553 meters. Okay, a building is 1,450 feet tall. How many meters tall is the building? Use the fact that 1 meter approximately equals 3.28 feet. Again, we need to know what we started with and then our conversion factor. Okay, so we are starting with a building that is 1,450 feet. Very important to have your label. We want to change that into meters, so feet's going to have to go on the bottom. And they told us that 1 meter, again, equals 3.28 feet. Our feet will cancel, so our answer will be in meters. When I multiply straight across, I get this crazy fraction. But then, because I'm looking for a specific amount of meters, I can divide that out. And I find out that 1,450 feet is really the same as 442 meters. All right, hopefully this is starting to make a little bit of sense, because now they're gonna change it up on you and make it a little bit tougher. Okay, this time a student ran the 50-yard dash in 5.8 seconds. At what speed did the student run in miles per hour? Okay, now they're not just changing one unit, they're changing yards to miles and seconds to hours. So now we're changing two things. We need two conversions. Okay, so we need what we started with and two more conversions. All right, what we started with was 50 yards in 5.8 seconds. We need to change to miles per hour. Okay, so miles measures the same thing as yards, so I'm going to put those together. Seconds and hours measure the same thing. I had to put seconds on the top so that it canceled with the seconds that were on the bottom, and yards had to go on the bottom because I already had yards on the top. So now all I'm left with is what I wanted, miles per hour. Now I need to go in and fill in those conversion factors. There are, if you look at your conversion sheet, 1,760 yards in 1 mile, and there are 3,600 seconds in 1 hour. Now when I multiply straight across, I end up with, let's see, 50 times 3,600 gives me 180,000, and 5.8 times 1,760 gives me 10,208. So when I actually divide those out, I get that this student is running a 17.6 miles per hour. Okay, so you always need one ratio for the information you're starting with, and then one per conversion factor. Okay, a runner is running 10 miles per hour. There's our first ratio, 10 miles per 1 hour. What conversion factors should be used to convert 10 miles per hour to feet per second? All right, I am changing two things, going from miles to feet, from hours to seconds. All right, so I know my miles need to cancel out, so I have to have them diagonally across from each other, and my hours have to cancel out, so those have to be diagonally across. And our new units are going to be feet per second. Miles and feet both measure distance, so those go together, and hours and seconds both measure time, so those will go together. Now I'm going to fill in these actual conversion factors. There are 5,280 feet in 1 mile. and there are 3,600 seconds in 1 hour. And I cancel out my units, miles, miles, hours, hours, which leaves me with the feet per second that I wanted. And when I multiply straight across, 10 times 5,280 times 1 gives me 52,800 on the top. On the bottom, I have 1 times 3,600. And then I'm actually going to divide those, and I'm going to get about 14.7 feet per second. All right, this last page I'm going to let you do on your own. If you want to come back, you can come check the answers, but I'm not going to do this one with you because this takes a long time. But make sure that you use your conversion sheet that you can find on Google Classroom. And then your assignment for tonight is on page 121, 9 through 30, all in the lesson quiz.